I will be talking today about Zarhus with full root file system on the CROSSCON Hypervisor. My name is Wiktor Grzywacz. I'm a junior embedded systems developer here at 3MDEP. I'm a member of the Zarhus team. Thank you for joining the presentation, and let's get into it. So first up is the agenda. We will be going over each one of these topics one by one. So first, I will give a quick overview of what the CROSSCON Hypervisor even is and what CROSSCON is as a whole. Then I will talk about why we felt a need to integrate Zarhus and enable full root file system access on there. I will quickly go over the steps that need to be done in order to get this setup to work. There will be a live demo of what we have achieved so far and a quick mention of the things we plan to do next. And at the end, there will be a Q&A. Okay, so let's get into the recap. So CROSSCON itself stands for Cross-Platform Open Security Stack for Connected Devices. And that's a mouthful, but it's basically an IoT system. It focuses on security and places emphasis on trusted services offered by Trusted Execution Environments, or TEES for short. It's open source, it's designed to be portable, and there is a repository with the demos available. Right now, there are only demos for two platforms, QEMU and the Raspberry Pi 4. Today, I will be focusing on the Raspberry Pi 4, and everything that is mentioned here in today's presentation will be relating to that. The CROSSCON Hypervisor is also based on the BAO Hypervisor. Also thought I should mention that this whole presentation is available at cfp.3mdep. If you click on the talk that's happening right now, you should have access to the PDF file of the presentation because there's a lot of useful links there, and there will be. So let's talk a little bit about the constraints of the current setup. So right now, the demo for the Raspberry Pi 4 uses a minimalist build root initramfs, and this makes it sort of difficult to work with the trusted apps. We always try to focus on solutions with Yocto, and it's really easy there to just add a new recipe for any tool that you need. And you also have access to a lot of layers that provide those recipes for you for a lot of stuff that we may need in the future. And it's a lot more convenient that way with Yocto. And we avoid sort of cross-compiling things so that they work. And yeah, so the lack of the tools in the build root initramfs and the compilers and the linkers makes pretty basic tasks, such as running a simple proof of concept program. It can make it difficult, which is why we wanted to integrate Zarhus into this setup. Also, gathering of logs is way easier once you have a root file system. You can just save them and do whatever with them. So let's jump into a quick visualization. I made a diagram here so you can better understand what we have done here. So as you can see, this is a diagram showing the CROSSCON stack on the Raspberry Pi. And here we have the hypervisor. and it runs different VMs. So this could be VM1, this could be VM2. And in the default demo, there are actually two VMs. One is the build root VM, and the other one is the OPTOS VM. And so what we have done with the setup is we have replaced the build root initramfs with our system Yocto-based Zarhus, and we've also enabled the full root file system for this. So how do you do it? Well, there are a couple of steps that need to be done correctly in order to get our setup to work. Firstly, obviously, we need to build the Zarhus image for the Raspberry Pi board. One very important thing to keep in mind here that we use the CAS container script for our builds. And one important thing is to make sure that the machine we are choosing is the Raspberry Pi 4-64, because there's also another machine that's recognized by the build system that's without the dash 64, and it actually builds a 32-bit system, which will not work on the hypervisor because the entire demo is based off of 64-bit systems. Then we need to configure the CROSSCON stack process. So there was the demo that I linked earlier has a couple of steps that need to be tweaked. Mostly they relate to editing of the device tree file. Some things need to be correctly assigned there. Mostly I'm talking here about the boot arcs section. We need to specify the correct console port to avoid serial issues. And we also need to specify our root file system there. Then also, maybe I can actually just show this right here. This is the GitHub page of the CROSSCON Hypervisor demo, and as you can see, by default, it uses an SD card, but by default you have to manually partition it. So one of the things that we thought would be good is if we just used the auto-generated by Yocto bmap and gz files, that we already have the two partitions, and we can avoid this manual formatting step with fdisk. Okay. Then finally we can boot and log in. There, if you're curious about the whole process and exactly how it needs to be done to get this to work, there's a full guide in the Zarhus docs. And also I wrote a blog post regarding the whole debugging of this integration and the process I went through when trying to get it to work. Again, all the links are available if you download the PDF of the presentation in the cfp.3mdep of this meetup. Okay, so quickly go over the current status. What we have working. We have obviously the Zarhus kernel working on the CROSSCON hypervisor, but we also have the rootfs mounting. A couple of things had to be done to get this to work. Obviously, I already mentioned editing of the device tree file, but also there's a file called that's on the rootfs called it's in slash etc fstab, and it's a file basically short for file systems tab, and it specifies to the Linux system the different partitions that need to be mounted. It's a file that's automatically generated by Yocto, and And when just using Zarhus as is, it obviously works. But during the setup of integrating Zarhus into the CROSSCON stack, that also has to be edited to get the rootfs2 bound. So that's something I thought I would mention. There were a lot of issues with the serial port in this integration. Mainly, I was initially very confused because of the correct port has to be specified in the device tree file, but with build root it does not. So that took me a little bit to find out. And there's also another more esoteric issue which we haven't been able to quite pin down yet, but I will show you that later when it's time during the demo. And we have a working Linux environment. So obviously, anytime we want to add a new tool, we can just add a Yocto recipe for it, and yeah, it's way easier that way. Here's the blog post again, and I guess we can jump into the demo. So I have a Raspberry Pi on my desk right now. We can open up Minicom, and we can see how it boots if I just plug it in. And okay, this is U-boot. And now we have to stop, just like in the demo. We actually have to stop here and tell U-boot to directly load and jump to our image. So we can do that using this command. And we should have our Zarhus system fully integrated with Yocto. So first, you can see that the CROSSCON Hypervisor is the first thing that boots. It starts mapping the VMs and assigning their interrupts, and then we move over to the kernel, as you can see. And finally, at the very end, we should be here, and we have the login screen. We can log in. We can see that we have Zarhus running, and yeah. So now I guess this is an opportunity for me to talk about something important. Obviously, a big part of the whole CROSSCON stack is making sure that the communications with the OPT OS are working correctly. And I guess one of the ways this can be done is using the Xtest application. So we actually have started work on trying to integrate this whole thing. As you can see, if we list the devices and grep T, we can see that we have already the drivers for all of this. But unfortunately, right now, if we run the command, some tests cause a... It should be any moment right now. Oh yeah, some tests cause an OPT OS stack dump and crash. And I guess now I will go back to the presentation so that I can talk more about this. So this is the roadmap. So the next thing that we want to do with this is fully support OPT OS and Xtest. When we get to a point where Xtest runs without crashing, then I guess that's pretty good. That's a very basic goal for the near future that we are aiming towards. And the second thing you might have noticed, oh yeah, we are currently working on this, on adding support for all of this in a PR. And the next thing is called the magic print K issue. So basically, if we go back to the to the logs, you might have noticed that at some point during the booting of the kernel, the output starts getting very choppy with a lot of new lines. And then also once we log in, this issue, once we log in, this issue persists. So this is actually intended. When I was working on the integration, I came across this big problem where I thought everything was finished, but suddenly the OS was just at some point during the kernel booting, it was just stopping, and I didn't know what was the cause. There was no errors or anything, and we were stuck on this. I was stuck on this for quite some time, but a fellow from the CROSSCON consortium pointed to me a workaround to this issue. Turns out if you pick a specific abort handler in the CROSSCON hypervisor and add a debug statement there, just a print new line, it appears to keep the output going and allow us to log in. We still are not sure what causes this, and it would be nice to find out the root cause behind it. Even though we have a working solution right now, it would be a lot better to be able to articulate why this is even happening and be able to fix it that way. So it doesn't alter the functionality of the whole setup, but it is very, very annoying. Okay, so if some of you would like to maybe contribute or have some clues, you can obviously contribute to the issue regarding the hypervisor abort handler print issue here. You can add to the existing PR where we try to add support for OpenTOS and Xtest. You can just raise an issue in Zarhus repo, or even better, join our workspace. There's a lot of people there, and your ideas would be appreciated over there. So if any of you would like to maybe tinker with the image or have some sort of ideas on what could be done there, but don't really have the time or want to go through the building process, I have uploaded the image, so you can flash it yourself and play around with it if you would like. Again, all of the links are available in the linked presentation. And finally, I guess it is time for the Q&A. If any of you would have some questions, then now is the time.
Yeah, thanks, Victor. That was good presentation. Yeah, just for those who don't know, you can go to cfp.3mdeb.com. Yeah. Thanks, Aaron. And there you can see the Zarhus developers meetup. You're going inside. You essentially get the list of the presentation. When you enter the presentation, yeah, that's the link. When you enter the presentation, you essentially will have a link to PDF. Of course, right now not all the PDFs are uploaded, but there will be, and we probably will also link the videos there. So for those who didn't watch, you could find the videos there. Like maybe getting back to the beginning of like what's the value of CROSSCON? How you, Victor, perceive value of CROSSCON? Can you like maybe? I have my own answer also, but I would like to first hear yours and maybe add something if needed, or maybe that's.
Well, sure. Well, right now the whole CROSSCON project is very sort of technical and theoretical, but I think they won't have a problem with finding applications of the whole stack in real life scenarios. I think there's a lot of place for security based stacks in IoT systems, and I think this is a solution that people could be interested in, definitely. But
Yes.
I would like to see maybe some more platforms being developed there. Personally.
Yeah, agree. Yeah, Raspberry Pi is like let's say first choice, and something like big audience. Like you already have big audience, but yeah, you're right. Like more platforms would be better adoption, more potential customers, more use cases. So my perspective on CrossCon is that having this Opti got like giving you like giving you certain properties, and it's very often very hard to understand the trusted execution environment from the perspective of the open source, open hardware person, because we think, okay, like platform owner have to own everything and have to know about all the software running on the platform. But it is not always the case, especially when you deliver the application based on those systems. You are kind of like a vendor of this hardware, and maybe some part of the code you would like to keep as like secret, or maybe you at least would like to isolate it from the regular workload. So some, for example, secrets handling, like a keys management, maybe some secure storage for some important data, maybe some operation have to be performed in this trusted execution environment, like maybe some crypto acceleration, or some, I don't know, TPM access, or some special hardware access should happen inside the trusted execution environment. This is normal architecture, like Android use that architecture all over the world. Like there are billions devices using that mechanism, and right now many platforms do not have this capability because of various reasons. So one reason is, for example, the design do not allow that. Like in case of Raspberry Pi, there is this video core and this weird Broadcom design, which is kind of shady sometimes. But then it also do not allow to run anything called video core unless you were reverse engineer that. I know there was effort related to that. So that's one part. Then you're getting on Raspberry Pi really a possibility of run trusted execution environment and have this partitioning. Of course, there are other hypervisors that could provide this partitioning, but this hypervisor leads you to the environment in which you have this trusted execution environment, which can provide additional security mechanism in case of deployment of the applications. Yeah, so I guess that's really big thing. Yeah, so Daniel also got good point that CrossCon got really a lot of interesting demos. There were not released publicly yet, but yeah, I guess there will be more and more things coming from CrossCon this year. There are actually there is this Daniel saying, I actually love their desire to launch a hypervisor on platform that do not have MMU. That's very nice. Like that's microcontrollers with Zephyr, for example. Or interrupt, like our platforms without interrupt, like generic interrupt controllers or global interrupt controller. I don't know what's the abbreviation for GIC. Like ARM v7M. Like I guess like ARM v7M is already quite a beefy microcontroller. But yeah.
Popular. And the JIC is general interrupt controller.
GPU or
JIC.
JIC is what?
General interrupt controller.
General, yeah. I thought that this is general. Yeah, I wondered what was like global general. I didn't remember what's the G in here.